All right, in this example, we're given some properties of a function and asked to sketch a graph of it, okay? And so let me just draw some coordinate axes here. And so first of all, we're told that this function has critical points at 2 and 5. So let me just mark where those would be. 1, 2, 3, 4, 5. Okay, so there's 5 and there's 2. Okay, so we have critical points at 5 and 2. That doesn't tell me, I can't really graph much just based on that. But the next property that we're given is that the derivative of the function is positive to the left of 2. So positive means that the function itself is increasing, right? If the derivative is positive, then the function is increasing. So I could maybe draw a little arrow. So to the left of 2. And it's positive to the right of 5. Okay, so over here I also have the first derivative is positive, so it's an increasing function. Okay, so I'll just draw a little arrow to kind of indicate what I know from that second property. All right. Now we also are given that the derivative, the first derivative, is negative between 2 and 5. So it's decreasing. The function itself is decreasing. All right, so there's my x-axis. This is my f of x axis. All right, so what is that telling us? It tells us that we have, so we have a critical point at 2. It's increasing to the left, decreasing to the right. So that tells us we have a local maximum there, right? We don't really know any more about the function. All I know is that it has to be, I have to have a local maximum. So let's say that, we have to kind of guess at a value, right? Let's say that the value is there. That's the value of f, the original function at 2. So then the function has to be increasing and then decreasing around that point. Okay. We can also see that at x equal 5 has to be a local minimum, right? Because the function goes from decreasing to increasing, assuming it's a continuous function, right? So if we say, let's say the value is down here, we don't really know what the value is, but if we give it a value, then we know that, okay, it has to do something like this. All right. So that's a sketch. We have a local maximum at x equals 2, and we have a local minimum down here. Local minimum at x equals 5. All right. Now, of course, we don't have enough information to get, an actual graph. So this graph is really not unique. As long as I have a local maximum and a local minimum at those 2 points, x equals 2 and x equals 5. So I could have drawn another, a different graph where maybe the maximum is here at 2, and then maybe it dips down and maybe the local minimum is like that at 5. So that would be another acceptable answer. There's more than one answer to this question. This graph here is not unique. All right, so let's I think that's it. That's all I have for this example. So I'll meet you for example 7.